Hello everyone. Today welcome to the introductory course on Ansys Workbench. We will be giving a brief introduction on the project schematic window of Ansys in this course. Why this is important, because when you start working Ansys, this will be the main starting point for your project. When you open the Ansys Workbench file, you will be seeing a window like what you see in the present screen. So how we will start from this point? So that will be explained in this session. So let's go and see the various options that are available in the Ansys project schematic. This window that you see here is called the project schematic. It contains all the connected, all the components that we use for the analysis. And let's go by each of the options. So this is called the menu bar, and we have different menus like file, is there, view, tools, units, extensions, jobs, and help. So let's go with file in the beginning. So in file we have got new, and this will help us to open a new file. Then we have open file. Open file will help us to open an already existing file, and the extension is WBPJ. That is the extension used for Ansys Workbench project. We have the save as button. These all are like normal Windows operations. And move back, then these are a kind of saved repository or web-based options which we will not be using in our day-to-day operations. Then we have import. Import and archive are two main important features through which we use to share the files from one user to another. Like import will help you to import a already archived file from a different user or from a different company or something, or it's another workbench file that is saved and stored. That is the archive file, and import helps us to open that archived file to the project schematic. Then we have archive option. Archive option help us to archive a finished project. There are options with which we can archive with the results or from the analysis, or we can clear the results and just archive what are the main things, like till the meshing part and the analysis setup will be archived. So these terms, it will be a bit new for this analysis setup, meshing. Those you might have. It will be a bit new for you from Ansys point of view. We will come to the in detail when we go into detail course on Ansys Workbench. Then there is a scripting. Scripting will help us to record some operations that are performed in the project schematic, and we will be able to rerun it by again run the script file. So record journal will record the operation that we are performing on the project schematic window, and by running the script we will be able to rerun the recorded journal. So those are like, again there is a list of files that were previously opened will be coming up here, and exit button closes the workbench window. Now moving forward to the next menu. So we have here view. We have refresh. These many options are there. Refresh is to refresh the whole project. Any project in the project schematic will be refreshed. I will show you an example, and then it will be clear for you. But let me first introduce all the options that are available. Reset workspace, it will reset all the unnecessary open windows again to a clean model. Again we have toolbox. Toolbox is what you see here. See, toolbox. This is a toolbox window. If this is hidden or something, if I say close it, so in order to get it back, we have to go and click the toolbox. Then we have the project toolbox customization. So at present you will see few components here, but there are many components that are available in Ansys that are hidden. In order to make it a clutter free, I have hide those things. In order to get them back, click on this toolbox customization. We will be getting all the components that are available in Ansys, and we can put a tick to get them back, and remove the tick. It will be hidden from the toolbox. So once I have closed the toolbox, but because it will reduce my project schematic windows space. Now I have, this is my project schematic. This is like where I will have the interconnections made. It will show you how each system is getting connected in the project schematic. Now I have a outline properties. These will be, I will be explaining in the due course. Then we have message. Message is where like we will get any error message or progress or warning message will be coming in this message window. If we have hidden it or closed in between, we can get it back by clicking this message window. Then there's a progress window is there. Progress window shows how the analysis is progressing, or say it's a kind of automated process, say optimization kind of process. Then in the processes window, it will be showing what is the process that is being performed here, or what is the process that if when you are saving, it will show how much percentage of it is saved, like that. It just shows the progress of the project. Progress window will show the progress of. Then we have a side help bar. Let's see, it will give you directly to the different help menus available. And we have show system one. Those are like general properties. These are the main things that we need. And in tools, this is the license preferences where we can connect which license we want to select. And there is options. So this option shows additional features that are available in Ansys settings, which we can use for later. Most of the time, we may not be using these tool options generally. And another important feature is the units. Why units are important? Because we know our engineering problems, they are all associated with units. Either it will be in SI unit or it will be in a imperial unit. Like when I say SI, it is Newton meter kilogram, Newton meter second. Say here you have the SI units is there here. See SI kilogram meter seconds Newton. Then we have metric system is there, which is again kilogram meter seconds degree Celsius, like that. Then we have the metric is there, which involves ton. So we should be very careful when we are selecting the unit system. The unit system used in Ansys should be consistent with what the geometry is. Say you have some geometry built in millimeters. The unit system is millimeter, a millimeter, ton, like that. But when you import into Ansys, you imported using SI unit system. So there, the mismatch can actually change the entire scenario, because then we are giving like is corresponding to 1 meter or something like that. It can cause a lot of confusion if we didn't give it properly. So our unit system should be properly defined, and it should be consistent with the CAD geometry. Then there is again like few things like display values as defined and display values as project units. Like this option is like, see, we can have one unit system displayed here, and this unit system will be used in the project schematic. And in our mechanical workbench window, which we'll be talking in later point of time, there we can have a different unit system than the project schematic if this option is selected. If display values in project units is selected, whatever unit system we select here should be consistently used in the mechanical window. So that is the importance of units. Again, you can see different unit systems that are available in Ansys. There's a lot of unit systems are there, and we can choose which one we want to be default or which one we want to be displayed in our long list, like which are ticked will be displayed, unticked will be displayed. So then they have given like characteristics of each unit system here. The angle is in radian, chemical amount is in mole, current is in ampere, length is in meters, and luminous in candela, mass is in kg, salt angle is in salt angle, SR, temperature is in Kelvin, time is in seconds. Like these are all various units that are associated with this unit system, SI. So if we go to the next one, you will see similarly some changes will be observed. Say, let me go to ton. So here you will see the length is in mm, mass is in ton, temperature is in degrees Celsius, time is in second, like that. So it's up to the user to be careful with the unit system, because as you know, Ansys is a programming language and it is like garbage in, garbage out. Whatever we put, it will be processing it and giving it out. If we are giving a wrong data, it will process the wrong data and give us a wrong output. So we should be very careful with the unit systems when we are analyzing. Then extensions are some advanced features in Ansys where we will be using some externally built or Ansys customization tool build extensions in our mechanical window to process more what is not there in the general Ansys. So this is the ACT extensions are a bit advanced courses that we will be discussing in later point of time. And this job is again submitting the answers in parallel or batch run or like something like remote solver. They are also will not be used in the general Ansys work. Then we have the help menu. Help menu contains different sections like Ansys, Workbench help, installation help, those things. So user can click on this and search and whatever the query he is having and can get it clarified. Now let's start with the project. How we are going to start? In Toolbox, if you see, there are three sections are mainly. This is the analysis systems. Analysis systems involve what type of analysis are we going to perform. So you can see here, mainly you can see model analysis, static structural, thermal, transient structural, transient thermal. These are the various analysis systems that we will be using to get our required solution outputs. We have many more these analysis systems are available in the Toolbox customization. Again, next part of the toolbox is the component systems. Component system is involved what is specific to a components, like what is specific to the our geometry or something. So geometry, say consider geometry is there. Geometry is associated with the one particular component, like my assembly is there. It will have one geometry. And then engineering data, this is a material point of view for Ansys. Then you have mechanical model where we'll have mesh details can be imported from different systems. Then we have the meshing separately itself where we can connect a geometry, then we can have a mesh setup passed on to it, and it can be again connected to different analysis. Then we have design exploration. This is again a kind of high advanced feature where we do optimization in Ansys. We have got direct optimization, parameter correlations, then response surface optimization. And design exploration is not a general tool, it's a advanced concept, and we will use it when we need perform some optimization work in Ansys. Then there is again ACT where we can create a workflow for a ACT building. So these are the features in the toolbox. Now let's start our analysis by putting a small static structural analysis here. So what we will be doing is we will be dragging and dropping the static structural button onto the project schematic. So now you can see it builds the static structural deck ready. Let me close this message and the progress bar so that we will get some more space. Now in static structural you can see different options are there. One, there are few component things from the component analysis coming in a static structural. You can have them dropped separately also. So it will be a separate block for geometry. This will be a separate block for material properties. And this will be a separate block for mesh. So what I will do is, again mesh will have its geometry associated with it. Or you can have your mesh model itself separately. Say you will be connecting this mesh onto, this geometry can be connected to here. So now it becomes a shared block. You can see like, see one line is connecting this geometry to the geometry of the meshed model. So one advantage of building with components is you can use this same geometry among different analysis systems or other components which are compatible with it. Again, I'm passing this geometry again to here. So after meshing, if I want to pass this mesh to here, see. Now what it will do? It will take the geometry from this model. This mesh will be done here, and that mesh will be passed on to structural deck. Now if you see, structural deck size got decreased. See, my default deck is this one. So I am reading geometry from one separate in the component systems. Then I am meshing it in a separate component system, and now the structural doesn't need these three options. So it will have the engineering data from the mechanical model itself, and from there will be setup will be there, which is the analysis setup, and solution results, which are the components of the structural systems. Say now I want to have a thermal analysis. I have the option to connect this thermal analysis deck to a structural. Now it is interesting to see the material data. It is connected between the structural and the steady state thermal. Geometry is shared between these two decks analysis systems, and model is also shared between these two analysis systems. Any change in any of these three features in the static structural will be changing the solution in the thermal analysis. That is the meaning of these connections. And in a similar way, say if I change this geometry, that geometric change will be affecting this mechanical model, and in that mechanical model change will be affecting this static structure. So this is how we build an analysis setup. Say we can have any number of connected decks in Ansys, and more in many number of connected analysis can also be performed. So before going to that, let me show you an interesting feature in Workbench. Say I have a thermal solution. I want to take this temperature to my static structural analysis. Say I drag and drop it onto the solution. Now this solution from the thermal will be passed at an input to the analysis setup. See this line? This line what it means is my solution is passed on to the another analysis setup, and this solution will be forming a load. It will be acting as a body force or a load on the next analysis, connected analysis. So this is a very important feature in Workbench because this helps us to get the various analysis connected together. This feature helps to highly reduce the complexity that is required during the APDL or the classic method that available earlier in Ansys, and it brings together a very good connectivity between each type of analysis, and it saves a lot of time because if we worked in classic in the same method, we need to write a lot of scripts or commands to perform this connecting operation, which is very difficult for a new user who is very new to analysis classical methods of Ansys. So now you can see one project schematic here. Let me save the project. So here you have the save button, or you can select from the file. You will be saving it. So you can see some save option will be coming for saving the project. You can save it. You can give a file name. I'm giving it test1 and save. So you can see the save window. If you see the progress here, okay, it already saved since it was not a big file, it saved very easily, or else you would have seen a progress here. And it saved with 0 messages. If there is any warning or something, we would have got it on the message window. I will show you an example of a warning. Say, let me save, try opening. Say reset. Okay, we have 0 message. Try refreshing it. Okay, let me try. Okay, let's wait for a moment. I'll show you what the warnings and messages one we can receive during our operation. Just wait for a moment. So this is the basic analysis set a project schematic window that generally exists in Ansys. So that was a small introduction on the Ansys project schematic. Now let's see a small example before, and I will show you various how refresh and updates are different. Those features I will show you from the example. Let's take a small example. So you can see this is a small project with a one geometry attached to it, and we have a static structural model, and you can see now everything is ticked in the solution. It means this model is fully solved model. For just for our clarification, I will put a thermal deck onto here. This is from simple examples. On putting it, you can see my engineering data, geometry, and models are shared between the static structural and the thermal analysis deck. But in the setup, you will see a kind of a different icon, and solution and results are question mark. So what does this means by this icon? This icon is the refresh icon. So you can do what you can do is right click. You can refresh. So once it is refreshed, when you give refresh, what it means like, okay, it is ready. It has read the data from whatever data was there from this model is applied onto this geometry, onto this analysis setup. That is what the refresh do. Now you need an update. Now it changed to another item. This is the update icon. So what update icon is? Yes, there is some updates required. So there it's the update icon. What is showing is like I need to have boundary condition applied to this model, and I need to solve the model. Once the model is solved, we will be getting ticks everywhere. Now it is question mark because there is no data present for this. So this set or there is some data available or the deck is ready, but it needs an updation. That is the objective was the update button. Now you can rename this by double clicking it here. Let's press F2 and type analysis 1, analysis 1, and let's give it analysis 2. So this, what is the advantage of this is like it helps us to identify what this analysis is without even opening the project. I'm giving like geometry 1. So we can rename all these features here. Now I will show you how to save this project. You can press this save button, and if you see the progress, you can see. Now you can see how the data are getting saved and what the use of progress window is to show you what the files it is saving and how and when it is ending. Now you have got a message also here. Let's see what is it like. Cannot be dictated in as install. This is some kind of informational warning. You have basically 3 types of messages will be coming in Ansys. One is informational, other will be warning, and the next is error. If there is any error coming in the message window, it means analysis cannot be processed without correcting that error. So we may have to look into what is the error that has occurred, and we'll have to correct that error. In warning, it is like there is something wrong or some inputs are not given as expected. Analysis will be continued, but it is up to the user to see the results and make a judgment out of it. So that are the 3 messages that we will get when Ansys operates. We will see those messages in detail during the other courses when we continue this course in course on Ansys. So now we have seen how we are getting this connected. Now we will go to archival also. We will see how we will archive a workbench file and how the file looks like after archival. Let's go to here, file, archive. So whatever is the working geometry is there, it will be showing that folder as the archival folder. Basically you can change this folder, and one important thing is it has changed the extensions. It is WPZ. It means that is the extension for the archival, and you can press the save. It will archive the entire workbench project into a single zip file. Earlier it will be coming as a folder with a lot of files inside it. So that is the archival part. And if you want to retrieve an archival, go to import. It will ask for the archival window. See, you can give the WPZ. You have to show it where it is and press open. It will open the archive window in a similar format. Or whatever the project schematic was built, that project schematic will be opened up. We have to save that archival as WPJ format once it is archival is opened. So these are the very basic steps that are required to start the working in Ansys. We'll be doing this in and out in our daily life, but before we start using Ansys, if we are clear on these topics, it will be helping us to get a better quick start on the usage of Ansys. Now, before we conclude the session, let me show you the various views the layout that we were talking. Now I have closed many things here. Let me close this toolbar and project schematic also. Now it's a completely blank screen. So if we want to get it to the basic mode, let's reset the workspace. So whatever we close or whatever is the initial setup, that will be displayed. This is again one important feature because we may be closing many things here and there to get the space and to get it matched up for our required needs. and we may not, if we are having any confusion on where to find and where to open it, just go here to the view and reset the workspace layout. Reset workspace, it will bring it back to the original state. So with this, I am concluding my session on introduction to Ansys Workbench. So this is like I am giving you a very basic understanding on the project schematic, how we will be operating in Ansys in the Workbench environment. So thank you.